Hi there students, this is Dr. John, your physics and math professor, and today we're going to be looking at a concave mirror in much more detail. I'm going to give you a whole bunch of different spots where the object could be and see where the image forms. So a concave mirror, this is where I've drawn the entire summary here. By the way, if you want to see this entire video, if you want to see this summary put onto a study sheet, a cheat sheet that you can download, just look at my website and it's just like this. You can download this for free. There's no need to register. There's no cost whatsoever. You won't find study sheets like this anywhere else. I want to be the go-to place for high school math and physics students so that they can get better grades. And if I'm helping you, please subscribe. That helps me an awful lot. I'm going to need at least 1,000 subscribers so that I can start getting some finances for these videos and be able to make more videos as well. Now back to the video here, the concave or converging mirror. Now this mirror over here, as you can see here with these objects here, these two green objects, is that the light all seems to come together at the focal point, which means light converges or comes to the focal point. You would think a focal point should converge light, hence this is a converging mirror. And this focal point, also the distance to the focal point, is considered a positive length. Now what I've done here is I've drawn out all the different spots where an object can be. I've drawn them all in green. Notice this F here is the focal point. This C is the center of curvature. Remember, we just go like this, and this would be how the how the mirror would curve like this. The focal length is about half the distance to the center of curvature. And I've drawn points here I call this region 1. This is just how I've named them. This is not how officially they're named. Region 1 is outside of the center of curvature. Region 2 is say from the center of curvature right up to the focal point. And region 3 is inside the focal point. And I've drawn those three different sections out here so that you can see them in more detail. Let's look first of all, what if we put the object outside of the center of curvature? I've done two examples for you here. So I have these two spots over here, and we're going to draw two rays of light. That's why these are called ray diagrams. One is this light green one. It hits the mirror, comes back and hits the focal point. That's called a converging mirror. It'll come to the focal point and continue on. The other one we draw from the tip here, and we make this orange one that comes down here. It would actually continue on, hit the mirror, and come straight back. I've drawn the objects far too big. Really, they should be about 1/10 the distance here, so they should be really tiny here compared to the focal distance or the center of curvature, and then you would see how it easily hit the mirror. I've just exaggerated their height so you can see them better. So it's going to come back here and come straight back, and they intersect right there. And this one over here, it would have the same ray that comes out and goes through the focal point, but the ray that goes through the center would come right here. So notice that they form a union right there and there, which would make this one here the image for this one, and this one here the image for this one. Now notice as your object gets further and further away, your image would get closer and closer to F and get smaller. Soon it would be very small. It would form this little distance right in here within this little triangle here. And as you get closer to C, your image would get bigger and bigger. Actually, if you hit right on C, right here, your image will be right here, exactly where C is, just upside down. You can calculate that using the lens formula or the optics formula. 1 over F would be 1 over whatever this distance is, 5 say, equals 1 over the object. Let's say that's 10 here. Then this here also has to be 10. The image also has to be 10. It's going to be upside down like that. So this is this first region over here. As you are infinitely far away, the image is really tiny, right close to the focal point there, and then it gets bigger up until here, up until you reach C. So that's this first region, which is these two green lines right here. So now let's look at these lines here between C and F. I'm going to go to region 2 over here. So region 2 over here, I've drawn 2 points. I've drawn them, this is the center, this is the focal point. I've drawn them closer to the center because you'll see what happens as we get closer to the focal point. So let's take a look at this one. This light green line comes here through the focal point and then keeps on going. The other one, we still have to go through the center. But notice in this case, we went through the center this way. This time here, we're going to have to go through the center sort of backwards, which means the light from here, from this point here, would go up, hit the mirror here, and then come straight down through the center of curvature. And then they're going to meet over here. Now notice what happens here. This one over here, this green one right here, is going to form an image right here, which is going to be a little bit that way of the center of curvature, and it gets a little bigger. As we move closer to F, notice it gets much bigger. And actually, if we tried to place this right here, right close to F, this image would be huge. Notice it's going to continue to get as big as this light green line. It's going to become huge over here. It's actually going to go to infinity. The height of the image here will go to infinity as we get closer to F. You can see that again from this formula here. If I did this, 1 over F is equal to 1 over object plus 1 over image. And if the focal length is, say, 5, we're taking that as 5. And if we place the object at 5, right at the focal length, what does the image here need to be? Well, these two are already equal, which means this needs to be equal to 0. The only way that can be equal to 0 is if the image goes to infinity. 1 over infinity would be 0. Another way that you could see this is this. If you take a look at this here, notice here how the orange line, if we were to take this object right over here and make it right close to the focal length, this here, the top of this would go through the center here. And notice how this black line here, which I've just started to draw from here very roughly, would become roughly parallel to this light green line. So as we hit the focal point here, the line from the top of this that goes through the center would be parallel with the line that goes here and through the focal point. So those two lines will never meet, will never form an image. Okay, now let's look at region 3 here. Region 3 are those that are inside the focal length, between the focal length and the mirror. Something different is going to happen here. Notice for all of these images have been real. Why are they real? Because they're on the side of the mirror where light should be reflected. We tend to think this is a wall here. This checkered line here is a wall. So light would not tend to come over here. You wouldn't think it would. So images should form on that side. That's how you can help to remember this. So these will be real images because they form where light should reflect. Just like these over here are real images because they're on the side where light should be. Now take a look at these over here. This one here is quite close to the focal length. I've drawn a dashed green line here, and then this continuous green line, it would reflect right here through the focal point, but also we could draw the line dashed backwards like that. And you're going to see why in a second. If we take the other point from here and go through the center, come back, the light's going to come and hit the mirror and come straight back. But we can also draw a dashed line here. And notice right at this point here is where we have those two lines intersect. But that's on the wrong side of the mirror. It's on the dark side of the mirror. It's on the side where light should not go. So this image here will be virtual. And take a look at this other one here. I've started to move it closer to the lens. And what happens here, this green line is the same. Goes through the focal point right there and comes back like this, the same as this green line. But the other one, notice here, I've drawn this through the center, coming back here, they join here. So as this object comes right close to the mirror, the image will be right at the mirror. But as we get closer to the focal point here, the image, will go further and further away and become bigger and bigger. The union will become higher and higher. It will actually go to infinity. So we have two infinities here. When we approach the focal point from this side, notice this green one over here gets really big that way. It gets really big negative image. But as we approach the focal point from the other side, we're going to get a really big positive image, a really big virtual image in the positive sense. So this goes to infinity. This goes to the opposite infinity, which is much like this graph here. If you remember this graph, if you're going to graph 1 over x, here's how you would do it. So it would go to infinity. As you get closer to x here, it goes to positive infinity. As you get close to x from the negative side, it goes to negative infinity. And that's similar here. The focal point here for a converging mirror is almost like your forbidden area. You can't put a line there. You can't put an object there. Or if you do, it will not form an image. So it's going to go to infinity in one direction and infinity in the other direction. So what I've done here is I've summarized all of them. All these red ones are real images. All these brown ones here are virtual images. Summarize these three different locations. So again, if you really find this useful, go to my website and I'm going to have a drawing of all this with the numbers labeled so you can see them and explain. I'm going to have both a converging mirror and a converging lens on the same sheet because they're practically identical except things are shifted to the opposite sides. So in another video, I'll do a converging lens and then I'll also do diverging mirrors and diverging lenses as well. Please like and subscribe and I will see you in the next video. Bye. Bye-bye.